All right, we're in section 1.3. We're on page 14 in our textbooks. Page 14. All right, first thing you need to know is a couple of definitions. All right, the first definition is a power. A power shows repeated multiplication. All right, so at its core, that's probably the most important concept of this section. Powers and exponents show repeated multiplication. The base is the number being repeated, and the exponent shows how many times a number repeats. So if I looked at 2 to the third power, does that mean 2 times 3, or does it mean 2 times 2 times 2? 2 times 2 times 2. Okay, so that just reinforces that repeated multiplication. All right, exponents, this is the exponent, the small number, tells me how many times the base, all right, repeats itself, is multiplied by itself. Okay, so in example 1, we're writing powers. We're not solving anything. It's important that you pay attention to the directions. All right, so directions say write the product as a power. So I'm looking at how many times my term repeats. Okay, so I have 2. In example A, I have 2 to the, how many times is it repeating? 4th power. All right, what about example B? I would have 4 to the, how many? How many times does it repeat? Very good, 4 to the 6th power. And then the same concept applies to variables. I don't have a value, but that's okay. X is being multiplied by itself how many times? How many times? 5. So it would be x to the 5th power. All right, so I'm just writing repeated multiplication as a power. Now let's look at it the other way around. Okay, what if you had, let's say, 5 to the 3rd power? How would you write that showing repeated multiplication? How many times would you multiply it by itself? 3. So you would say 5 times 5 times 5. All right, I want you to do that with m to the 6th power. I want you to write that showing repeated multiplication. All right, so how many times would I multiply m by itself? 6 times. Very good. The exponent tells me 4, 5, and 6. All right. Okay, so that's it for example 1. Now in example 2, now I'm actually evaluating. Okay, so again, paying attention to directions is important. In example 2a, I'm evaluating, so 7 squared. I'm going to... Now, I know that most of you know how to evaluate 7 squared, but I'm actually going to teach you how to do it in your calculators. All right, go ahead and get out your calculators, please. All right, so we're going to start by entering the number 7 on our calculators. And then under the circular button, you see the button that has an X with a shaded in box? An X with a shaded in box. So you're going to hit that button, punch that button, and now you have a blank box where you can enter whatever value the exponent is. So in this case, it's a 2. So you're going to enter the 2, and then you're going to hit the equal sign. And now it's evaluated your exponent. So instead of, in your calculator, going 7 times 7, however many times, now you can just use your exponent button. And 7 squared, yes, is 49. All right, so I want you to evaluate 4 to the 3rd. And of course, we know 3 to the 1st and 15 squared. Go ahead and evaluate these next 3. Use your exponent button in your calculator if you need it. All right, so 4 to the 3rd power is 64. 3 to the 1st power? Just 3. Okay, so it's just one time, 3. And then 15 squared. What is that going to be? Very good, 225. All right, 15 squared. All right, now let's look at example E. 10 raised to the power of 0. Go ahead and put that in your calculator. 10 raised to the power of 0. 10 raised to the power of 0. Well, that's surprising. What's my answer?
0.
Nope. Put it in your calculator. The answer is 1. The answer is 1. Take any number. raise it to the power of 0, your answer will always be 1. That's your rule. So what is 52 raised to the power of 0? 1. What is 18 raised to the power of 0? 1. Okay? That's your rule. Now 0 raised to any power will always be 0. Okay? Doesn't matter how many times you multiply by itself, it's always going to be 0. Got it? All right, so those two rules you need to remember. All right, now in example 3, we're evaluating powers with variables. So this kind of ties into our lesson from yesterday, making those substitutions and solving. But since we're doing powers today, obviously these variables are going to have exponents attached. So we start off with our original expression, x squared. We make our substitution, 9 squared. And what is 9 squared? What is 9 times 9? 81. All right, I want you to do the next two on your own. Evaluate b to the third when b is 7, and c to the fourth when c is 2. All right, so original expression, b to the third, make our substitution. It's going to be 7 to the third, and what's our answer? Whoa, 7 to the third?
21.
Nope. 343. Why is my answer not 21? Why is it not 21? Loza? Very good. The exponent tells me how many times I multiply the number by itself. Okay, it's not 7 times 3, but 7 times 7 times 7. All right, so now c to the fourth. I make my substitution, and now I have 2 to the fourth. All right, and what's that going to be? 16. All right, who got them both right? Anybody get them both? Any questions? If you missed one, do you see what you did wrong? Yep, okay. All right, and if you understand that, that's everything you need to know for 1.3.